kidding. Did I scare you? Well, here is your lesson, what you've been waiting for. First of all, please get out your formula sheet. Remember the colorful ones that I gave you, the half sheet? If you've lost it already, please kindly ask me, and I will give it to you, okay? But you gotta be kind, all right? So you guys, please take notes on 5-4. AIM, how do you use the sum and difference formula? Yes, you have to memorize, okay? Now, why don't you locate that on your formula sheet? Your formula sheet is the color of your skin tone, remember that, okay? Now, how do I use the sum and difference formula to evaluate the trig functions to verify identities and solve trigonometric equations? Please look to the whiteboard to see the formulas as well. I will leave it there until we take the test, okay? The test, you're going to be required to memorize these formulas. Now, what I want you guys to first do is this. Can you guys please enter your enter it to your calculator on the same window, okay? This and this, okay? So this is scenario A, this is scenario B, okay? Now, this guy, you can see that there was a horizontal shift to the left of 2. This guy is 2 graphs. You're kind of adding them together, right? Cosine of 2 radian and a cosine of x. I wonder what that graph looks like. Okay, graph those. Give you a minute. Okay, stop the video. All right. Well, what did you guys notice about this cosine x plus 2? So it looks like we've distributed the cosine, which is kind of strange. Now, you're right. The conclusion is, are they the same, or are they same, or different? You're right. These are different, not the same thing. What do you suppose will happen for this guy here? Sine of x plus 4 versus y equals sine x plus sine of 4. Yep, smarty pants. They look same, but they are very, very different, okay? So what I wanted to prove to you is that this is like sum and difference. It has to do with the formulas, okay? But what I want to prove to you is that these are indeed not the same thing. Okay, so let's look at here, okay? Here's your first sum and difference formula. So I'll show you all of them at once, okay? If you look to the side of the board, you can see it as well, okay? Now, what I want to show you here is this. Sine, right, u plus v, which is kind of like this, right? It's like you're taking 2 angles, like 20 degrees plus another 25 degrees. And what happens is what we're saying. That means you can take individually. Sine of, I'm going to rewrite this so it's easier for you to remember. So they're very similar, except when it's plus here, it's minus. You see the sign difference, right? They're the same kind of sine and cosine, right? Except here, they write cosine u because they want to be consistent with this. But I like to just write it as sine u cos v plus sine v cos u. You're taking the sine of u and the sine of v, and the cosine of v and cosine of u, right? And then the plus and minus is different. That's for sine. Now cosine, what do you notice? Why don't you discuss with your neighbors what's different between them? Okay, you should have realized that when it's plus, it's negative here. That means when I put these together, you guys, I like to write it like this. Cosine u plus or minus v is going to equal cosine of u, cosine of v, minus plus, right? Because they're opposites. And sine u, sine v. They'll be easy to memorize, okay? I promise you. And it makes your life a lot easier if you actually remember them, okay? All right, let's go to tangent. Again, very same but different, but I'm going to rewrite it here for you. Tangent, sum or difference, right? Sum and difference, sum and difference, sum and difference. So now, it's like taking 2 angles, adding it together, 2 angles, subtracting it together. Tan of u plus or minus v is going to equal tan u. They both have tan u, but signs are different, so plus or negative. Tan v all over 1, but now the signs are different here on the denominator, so it's minus plus here. Tan u, tan v. Okay, absorb these formulas and get used to them. Familiarize yourself, and we're gonna go right into our examples. All right. All right. Stop the video if you have to, and just soak it all up and find your formula sheet, please. All right. Welcome back, everyone. So now we're gonna move on to part 1, the real. Okay, we're gonna try some. Evaluate trig functions using smart values. And you know what your smart values are? Your smart values are the values that you know the sine and cosine of, in which case you don't need a calculator for. Using sum and difference formulas, okay? So get your formulas ready, okay? So here we go. Oh my god, cosine of 15 degrees, what the factor, right? You're gonna need a calculator, Maybe, maybe not. But let's use special and smart values. Special and smart values is what we're going to use, okay? So let's use that. All right, now what value do you know that's very close to cosine of 15? And you could write it in many, many different ways, okay? So in other words, cosine of 15 degrees, it's the same thing as cosine of, if you want to use difference, let's use difference. How about 60 degrees? I know that's what you were thinking. And you know another one. Oh my God! What's 60 minus 5? That's 15 degrees, right? Okay, now you know that. That means we're going to use the difference formula for cosine. Difference formula for cosine. So on the side here, I like to write that, okay? Difference for cosine is what? Cosine u, cosine v. Is it minus or plus? Plus. Sine u, sine v. Write that on the side there, okay? So you keep track of this, okay? Now you remember, this is your u, this is your v. So let's do that, okay? So let's do cosine of 60 degrees, cosine of 45 degrees, right? Plus sine of 60 degrees and sine of 45 degrees. And these are all things that you know. So you see how we don't need a calculator eventually? So we get half here, we get 1 over root 2 plus root 3 over 2 and 1 over root 2 here. That's all just your unit circle. And you guys, calculate this and you get root 2 plus root 6 all over 4 is what I got. If you don't believe that this is true, go ahead and plug it into your calculator now. Go ahead and plug into your calculator cosine of 15 degrees. Enter and see what they give you. Make sure you're rounding to the right digits. And here, plug this in. Root 2 plus root 6 divided by 4. So parenthesize this, right? And see if you get the same value. And indeed you do, okay? All right, and think about what it should be. You know, cosine of 15 degrees, think about it. Cosine of 15, if you think about this right here, right? Cosine of 30 is about right here. Cosine of 15 is about here. So is your cosine going to be longer or shorter? Think about that, okay? Think about whether your cosine should be longer or shorter than cosine of 30. Because cosine of 30, you know for sure it's root 3 over 2. Okay, so check that. Let's go to example 1. Find the exact value of these two. Okay? If you think you got the gist of it, stop the video and just check for my solutions, okay? Looks like they're all cosine, huh? So this is pi over 6 plus pi over 3. So it looks like we're going to be using the sum formula for cos. So I like to write that again. Cos, it's going to be u cos of v minus sine of u sine of v. Throw your hands up if you've already memorized the formula. Good for you, okay? All right. So now here, so let's write this out. Cosine of pi over 6 cosine of pi over 3 minus sine of pi over 6 sine of, minus or plus? I'm sorry, plus, okay? Oh, wait, plus with minus, sorry. Okay, sorry. I was looking at I should have looked at the original. Sine of pi over 3, okay? Now, I know you're too quick on this, so it's root 3 over 2 times 1 over 2 minus 1 over 2 root 3 over 2, okay? Now, I want to show you something. When you solve this, you get indeed 0. But you see how this and this, they look same, but they're very, very different, right? So let's prove that. What's cosine of pi over 6? That's going to be, what? Root 3 over 2. What's cosine of pi over 3? We know that's half. And when you add that together, root 3 plus 1 all over 2. It's not the same thing. They're not the same thing, okay? They're not the same thing. Got it? So what I'm trying to do is prove to you again that these are indeed not the same thing. Sum and difference formula needed here. This is just a sum of two quantities, okay? All right. Here we go, part 2, next video.